This is the video key to the Exam 1 practice test. Problem 1 is to sketch the graph of this piecewise defined function. I notice that it changes pieces at 1, so I'm going to draw a little line here for myself to remind myself to change here. Okay, on the left side of the line where x is less than 1, it wants to be x squared. So I know that 1 squared is 1. I'm going to put an open dot there since it's less than 1. And then 0 squared is 0, negative 1 squared is 1, negative 2 squared is 4. So I want to draw the function like this. Okay, on the other side of the line it's negative x plus 2. So I'm just going to calculate a couple of points. So when it's 2, negative 2, I get 0. So it's 0 here. When it's 3, negative 3 plus 2 is negative 1, so I get negative 1. So it's right here. And it looks like my two functions join up, which they don't always. So I'm going to go ahead and fill this in. Great. Number 2, find the equation of the line with slope 4 through the point 1/2, 2. I like to use this formula, y minus y naught equals m times x minus x naught. The point is x naught, y naught, and the slope is m. So I have y minus 2 equals 4 times x minus 1/2. I'm going to add 2 to both sides and distribute this 4, so I get 4x minus 1/2 times 4 is 2. And then this plus 2 went over there, so that's plus 2. So then I get y equals 4x. Moving on to page 2. Cookie Company. Fixed cost is $9,600. The variable cost is 25 cents a cookie, and the cookies sell for $2. So my cost for X cookies can be given by this formula. It's $9,600, that's the fixed cost, plus 0.25x. And my revenue, if I sell X cookies, is 2x. So I break even when my costs and my revenue are the same. So I want to solve 9,600 plus 0.25x is equal to 2x. I'm going to subtract 0.25x from both sides. And I'm going to get 9,600 is equal to 1.75x. That gives me x is equal to 9,600 divided by 1.75, which if I get my calculator up here, $9,600 divided by 100 divided by 1.75 $54.86, approximately $54.86. Okay, graph the equation x equals y squared. What I'm going to do here is it looks like x depends on y, so I'm going to put in some y values and get some x values. So here's my x-axis and here's my y-axis. I'm going to put in these numbers. Y is negative 2, y squared is 4. If it's negative 1, x is 1. If it's 0, x is 0. I get a 1 here and a 4 here. So graphing those, y is negative 2, I get 4, negative 1, I get 1, 0, I get 0, 1, I get 1, and 2, I get 4. The other way to do this is to remember the shape of y equals x squared and then just turn it over on its side. Moving on to page 3. I have a function here, g of x equals x squared minus 2x plus 4. G of negative 2 is g of negative 2 equals negative 2 squared minus 2 times negative 2 plus 4, which is 4 plus 4 plus 4, which is 12. Okay. For g of x plus h, I'm going to plug x plus h in. I get x plus h squared minus 2 times x plus h plus 4, which is x squared plus 2xh plus h squared minus 2x minus 2h plus 4. I don't have any common terms, so that's it. All right. Number 6, difference quotient. Okay, f of x plus h is the hardest part to put in, so I'm going to calculate that separately. Here's my f. I get x plus h squared plus 1. That is x squared plus 2xh plus h squared plus 1. Okay, so my difference quotient here is equal to x squared plus 2xh plus h squared plus 1 minus f of x, so minus x squared minus 1, I'm distributing that minus over both parts, divided by h. Notice my x squared cancels with my x squared, my plus 1 cancels with my minus 1, so I get 2xh plus h squared divided by h. I can factor an h out of the top, so that's h times 2x plus h divided by h. Now my h's cancel, and I get 2x plus h. All right. Next page. For each function, state the domain. And I don't care how you state it. So for domains, there's 2 rules that you'd have to watch out for. The first one is even roots can only be taken of non-negative numbers. And the second rule is denominator cannot be 0. So looking at part A, we don't have a denominator, so I don't have to worry about that one. But I have to make sure that what's in the root there is a non-negative number. So I need t minus 2 greater than or equal to 0. If I add 2 to both sides, that gives me t is greater than or equal to 2. I can write that like this. T such that t is greater than or equal to 2. Or I can write it like this. I can say 2 with a square brackets up to infinity. Okay. For part B, we don't have a root, so we don't have to worry about the first problem. We do have a denominator, and we can't let it be 0. So I need x minus 5 not equal to 0. So that means I need x not equal to 5. So I can write x such that x is not equal to 5. That's probably the easiest way to write it. Or you can write it in words. All x such that x is not equal to 5. Okay, number 8, I'm supposed to solve this equation. I can either try to factor it, or I can use the quadratic formula. I'm going to show the factoring version because I know this one factors since I wrote the exam. I need numbers that multiply to negative 24 and add to 5. 24 has a lot of factors, but 8 and 3 are two of them. And if you make the 3 negative, they add to 5. So what I have is this equation is equivalent to saying x plus 8 times x minus 3 is equal to 0. When a product is 0, you know that one of the two factors is 0. So this gives me x plus 8 equals 0, or x plus 3 equals 0. This gives me x equals negative 8, or x equals negative 3. So my solutions are negative 3. Oh, sorry, that should be positive 3. Because this is a minus. 3, negative 8. Doesn't matter what order you write them in.